Hello everyone, welcome to today's session. Today we are going to solve exercise 4a of your Concise physics textbook, that is from chapter 4, refraction at plane surfaces. Today is the last session for solving exercise 4a. If you have not watched our previous videos, please watch those videos for better understanding and the clarity of the concepts discussed over there. Let's begin. Question number 21. We start with question number 21. Look at the screen, read the question thoroughly. A ray of light A incident from air suffers partial reflection and refraction at the boundary of water. So you can see the diagram on the board. The question first, complete the diagram showing the reflected ray B and the refracted ray C. You have to show the reflected ray and the refracted ray. As you know that when a ray of light traveling from air to water, that is from rarer to denser medium, partial reflection occurs. So the reflected ray is going back to the medium and the reflected ray is, we can name it as B, and draw a normal to the point of incidence, and most of the rays will be refracted to the denser medium. So the refracted ray, since the ray of light is traveling from rarer medium to denser medium, it bends towards the normal. So name it as C as the refracted ray. So B, reflected ray, I can mark it as reflected ray, and C being refracted ray. Okay, clear? So we have marked reflected ray and refracted ray very clearly on the diagram. Mark the, show the direction of the light also. Second part, how are the angle of incidence and angle of refraction related? So what is the angle of incidence? The angle between incident ray and the normal angle of incidence. What is angle of refraction? The angle between the refracted ray and the normal. Mark the normal as n dash. Alright? Okay. n dash. So we have to show or write a relation between angle of incidence and angle of refraction. As you know, the relation between angle of incidence and angle of refraction is given by Snell's law. Snell's law states that the refractive index of water with respect to air is equal to ratio of sine of angle of incidence to sine of angle of refraction. So this is the relation. So we can state it very clearly. So that's all. Clear? Now moving on to question number 22. Look at the screen. The diagram alongside shows the refraction of a ray of light from air to liquid. As you can see on the board, a ray of light is being refracted from air to liquid. So first task, write the value of angle of incidence and angle of refraction. So in the first part, so the angles are given. Look at this angle. These angles are angle of incidence. No, this angle is not angle of incidence. This is glance of angle of incidence. The angle of incidence being the angle between the normal and the incident ray. What is the total angle? That is 90. 90 minus 30. The remaining angle will be 60 degree. So this will be the angle of incidence. So I can write angle of incidence as 60 degree. Clear? So what about angle of refraction? Look at the diagram carefully. Is this angle of refraction? No, this is not the angle of refraction. Angle of refraction is the angle between the normal and the incident ray, refracted ray. So this is the angle of refraction. How much value it is? 90 minus 45, that is 45 degree. So the angle refraction comes out to be 45 degree. So the first part is over. What is the second part? Use Snell's law to find the refractive index of liquid with respect to air. So in the second part, we have to find the refractive index of liquid L with respect to air. Refractive index of liquid with respect to air. Alright. So what is Snell's law? Sine of angle of incidence to the sine of angle of refraction. So we know we have the value of sine of angle of incidence. Sine of angle of incidence being 60, sine 60 divided by sine, what is the angle of refraction? 45. So from the logarithmic table, we get the value of sine 60. Sine 60 is root 3 by 2 divided by sine 45 is root 2 by 2. You can refer the value of sine 60 and sine 45 from the logarithmic table. Alright, so we get it as root 3 by 2. So refractive index of liquid comes out to be root 3 by 2. What's the value of root 3 by 2? Solve it and see. It is coming out as 1.22. Clear? So using Snell's law, if you know the value of sine of angle of incidence and angle of refraction, we can calculate the refractive index of the given medium with respect to air. Is it clear? Okay. Now consider the case of question number 23. The question number 23 states that the refractive index of water with respect to air is mu W, and refractive index of glass with respect to air is mu G. With respect to, how do you read it as? Refractive index of glass with respect to air. It's given. Our task is to express the refractive index of glass with respect to water. The answer lies in the question itself. Read the question again. Express the refractive index of glass with respect to water. So we can write refractive index of glass with respect to water is equal to, the answer lies in the question itself. You just you write the answer as you read the question. Ratio between refractive index of glass divided by refractive index of water. So refractive index of glass with respect to air upon refractive index of water with respect to air. So this is the answer. So you can express refractive index of glass with respect to water as the ratio between refractive index of glass with respect to air to the between refractive index of water with respect to air. Clear? So don't get confused. Okay. Now coming to question number 24. What is question number 24? What is lateral displacement? Draw a ray diagram showing the lateral displacement of ray of light when it passes through a parallel sided glass slab. So what is lateral displacement or lateral shift? You know the definition. Lateral displacement or the lateral shift is the perpendicular shift of light ray from its original path. This is happening when the refraction is taking place through a glass slab. So we have to show what is lateral displacement. Definition part is over. Lateral displacement is the perpendicular shift of light ray from its original path. Okay. Now let us consider the case of refraction through a glass slab. Draw a glass slab. Alright. A parallel sided glass slab ABCD. An incident ray of light is striking the surface AB. Draw the normal to the point of incidence. Mark the angle of incidence there. Medium air and medium glass. Alright. So a ray of light is traveling from rarer medium to denser medium. It is being refracted and bent towards the normal. Alright. So N dash being the normal, PQ being the incident ray, angle I, angle of incidence being the angle between normal and the incident ray. Mark the angle of refraction as R, as the angle between the normal and the refracted ray. And the refracted ray QR is striking the surface DC of the glass slab. Again, it is ready to emerge. Draw a normal to the point of incidence. What happens when ray of light is traveling from denser medium to rarer medium? It bends away from the normal. And the angle between the emergent ray RS and the normal is known as angle of emergence. Clear? So the refraction part is over. We have to show the lateral displacement. How do you find out the lateral displacement here? So we have to compare the shift produced in case of emergent ray with respect to the original path of the light. Where is the original path of the light? It is missing, right? So do one thing. If there was no glass slab, you know light travels in a straight line. So with geometry, what do you do? If there was in absence of glass slab, light ray would have traveled in a straight line like this. Straight line path. Now you can compare. What you can show the lateral shift. So that this is the original light ray, this much shift. So I can mark a shift here as xy. So I can mark xy as the lateral shift or lateral displacement. Okay, mark it and label it xy as the lateral displacement. Is it clear? So we have shown the lateral displacement, angle of incidence, angle of refraction, angle of emergence. Anything else is left over there? Question number 24. When it passes through, we have to show the lateral displacement. Alright? Okay. So diagram is complete. So this is the refraction through a glass slab, being one of the important ray diagram in this session. Okay. Now let us see what does question number 25 demand. A ray of light strikes the surface of a rectangular glass slab such that angle of incidence in air is 0 degree, second 45 degree. In each case, you have to draw the ray diagram to show the path taken by the ray as it passes through the glass slab and emerges from it. So first, when there are two cases for angle of incidence 0. So for angle of incidence 0, as you know that this case of normal incidence. In case of normal incidence, let us draw a glass slab. So let us draw a glass slab, and for normal incidence, it passes undeviated. Angle of incidence 0. Okay, so this is the ray diagram for refraction through a glass slab for normal incident, that is angle I is equal to 0. Now the second part. What is second part? For angle of incidence 45 degree. Angle of incidence 45 degree. So we can draw a glass slab over here. With the help of a scale, draw neat ray diagram. Glass slab A, B, C, D. And a ray of light being incident at the surface AB at an angle of incidence. Angle I is equal to 45 degree. Mark it. As you know, it is being refracted, bent towards the normal. This is angle of refraction, and as you know, it is emerging from glass to air. Draw a normal, it bends away from the normal. Okay, if there was no glass slab, light ray would have traveled in a straight line path. This case we have already discussed several times. So we have PQ as incident ray, QR as refracted ray, and RS as emergent ray. And angle E, the angle between emergent ray and the normal, is called angle of emergence. Okay, so we have marked all the incident ray, refracted ray and emergent ray. So we have shown the path very clearly. Clear? So emergent ray, refracted ray and incident ray, and we marked all the angles also. So the ray diagram is complete. Is it clear? So the angle of emergence will be, of course, should not forget to mark angle of incidence in case of refraction through a glass slab. You know angle of incidence is equal to angle of emergence because incident ray being parallel to emergent ray. So that what will be the value of angle of incidence? Don't forget to mark it as 45 degree. Angle of emergence as 45 degree, because in case of refraction through a glass slab, incident ray and emergent ray are parallel to each other. Angle of incidence is equal to angle of emergence. Clear? As simple as that. Now moving on to question number 26. In the adjacent diagram, AO is a ray of light is incident on a rectangular glass slab. Again the case of glass slab is coming up. Complete the path of ray till it emerges out of the glass slab. That is the first part. So AO is the incident ray. Let us complete the ray diagram. I hope by this time all of you are expert in this topic of refraction through a glass slab, and you must be able to do it now. Angle of incidence, it is being refracted and bending towards the normal, and the angle of refraction, and draw a normal, it is bending since it is moving from air to glass or glass to air. The emergent ray bend away from the normal. Clear? So we have completed the first part. AO, B, C. Name the OB is the refracted ray, BC is the emergent ray. So that part is over. In the diagram, mark the angle of incidence. Angle of incidence we have marked. Then angle of refraction. Alright, that is also marked. How is the refractive index of glass related to angle of incidence and angle of refraction? So in the second part, angle I and R is marked clearly. So the relation between angle of incidence and angle of refraction is given by Snell's law. So I can write according to Snell's law. Snell's law, refractive index of glass with respect to air is equal to sine of angle of incidence to sine of angle of refraction. Clear? So that part is over. Moving on to the C part. C part. Mark the angle of emergence by the letter E. How are the angles I and E related? So I can mark the angle of emergence, the angle between emergent ray and the normal. Angle of emergence is being marked as E. So what is the relation between angle I and angle E? So in case of refraction through a glass slab, all of you know angle I is equal to angle E. Angle of emergence is equal to angle of incidence. Clear? So that's the relation. Okay. Moving on to the D part. Which two rays are parallel to each other? Name them. Which two rays will be parallel to each other? Since angle of incidence and angle of emergence are equal, incident ray and incident ray AO parallel emergent ray BC. So the incident ray AO parallel BC, since angle of incidence and angle of emergence are equal. So that part is over. Moving on to question number E. Indicate in the diagram the lateral displacement between the emergent ray and the incident ray. State one factor that affects the lateral displacement. So lateral displacement. So this is an all-in-one question. So all types of questions have been included in this. In 2, 4, 5 parts. Okay. How do you mark the lateral displacement? For that we have to trace the original path of light. In absence of glass slab, light ray would have traveled in a straight line. So the perpendicular shift from its original path, just I mark it as xy. So xy, this is the lateral shift, lateral displacement or lateral shift. Mark it as lateral displacement. So I can write xy is the lateral displacement. Yes. So state one factor that affects the lateral displacement. The lateral displacement depends on what? What are the factors affecting lateral displacement? Thickness of the glass slab. Okay, I can write thickness of glass slab. Thickness of glass slab. Then color of the light, wavelength of the light. Then what else? The angle of incidence. Okay. So these are the factors affecting the lateral displacement. We have been asked to write only one factor, that is thickness of the glass slab. So that part is over. Clear? Okay. Now moving on to question number 27. A ray of green light enters the liquid from air as shown in this figure drawn on the board. Look at the board very carefully. The angle of incidence, that is angle 1. Angle 1 is given as 45 degree, and angle 2, that is the angle of refraction, is given as 30 degree. Alright. So it is marked here. The first task, find the refractive index of liquid. Refractive index of liquid with respect to air in terms of angle of incidence and angle of refraction. All of you know the Snell's law, that is sine I divided by sine R. So what is the sine of angle of incidence? Sine 45 upon sine 30. Clear? From the logarithmic table we are getting the value of sine 45 as 1 by root 2 divided by sine 30, it is 1 by 2. So 1 by root 2 divided by 1 by 2, coming it out as root 2. Clear? So what's the value of root 2? 1.414. So that's the refractive index of the liquid with respect to air. So that part is over. Now the second part, the B part. Show in the diagram the path of ray after it strikes the mirror and re-enters in air. Mark in the diagram the angles wherever necessary. So this is the refracted ray striking a mirror kept in water. What will happen? The mirror will reflect the ray of light back to the liquid. So there is a reflected ray. You can mark the reflected ray. So draw a normal to show the angle of incidence and angle of refraction here. So angle 2 is being 30 degree, angle I being 45 degree. So the alternate angle will be equal. So the angle of incidence in the water will be 30 degree. Mark the angles 30 degree. Since angle of incidence is equal to angle of reflection is also 30 degree. Mark the angle clearly. So this is the reflected ray back to the liquid and striking the boundary between air and liquid. The ray is ready to emerge out. How will it will emerge out? Since it is moving from denser medium to rarer medium, it will bend away from the normal. Clear? So that is the emergent ray. So what is the angle of incidence in the liquid? The alternate angle, if this angle is 30, the angle of incidence in the liquid will be 30 degree. And of course, the angle of emergence will be equal to 45 degree. That is the angle of emergence. So we have clearly marked the angle of incidence, angle of reflection, angle of incidence for the ray in the liquid, that is 30 degree, and angle of emergence as 45 degree. So that we can name the ray also. For example, P, Q, R, S, T. Clear? Okay. So here also the partial reflection will take place. If you want, you can mark the ray as the reflected ray, partial reflection. So that is angle of incidence will be equal to angle of reflection being 45 degree. Okay. So this angle, the emergent ray will be parallel to each other. Okay. They will never meet each other. Okay. So that part is over. So moving on to the last part, C part. So B part is over. We have marked in the diagram itself. Redraw the diagram if plane mirror becomes normal to the refracted ray inside the liquid. Very simple. You can just redraw it. Plane mirror is parallel. So the medium, air and liquid. We have separated a boundary between air and liquid. Draw a normal and the incident ray being incident on the surface and it is being refracted. Refracted ray, what you have to do here? You have to keep a plane mirror. Keep a plane mirror at 90 degree in the normal position. 90 degree. So what will happen? When the plane mirror is placed at 90 degree, the light rays striking the mirror, it will reflect back to the original path. That means light ray retraces its original path. Light rays are reversible. It shows that light ray will reflect back along the same path. Light rays are retraceable or light rays are reversible. Clear? So the diagram is completed. So what is left over there? State the principle used. What is the principle used? Principle of reversibility. Principle of reversibility. Reversibility of light. Clear? So light rays are reversible. When striking a mirror placed at normal and 90 degree, light rays are reversible. Is it clear? Okay, that's all for today. Thanks for watching.